have a reaction that goes from A to B, which has a equilibrium constant K, what will be the equilibrium constant of B to A? It will be 1 by K. We did this part, yes or no?
Yes.
Okay. So on the basis of that, generally from chemical equilibrium, most of the question is from this concept, and there is a question here. Please do it. Then we, after doing some questions on this important topic, then we will move to amines. No, very good. Was this Alan? Alan, very good. Any answer from any one of you? Okay, I'm going to explain. I'm going to share a new screen and then explain. Alan, are you able to see a new screen?
Yes, sir.
The same question I just pasted here. Now you can see. First of all, you are going to look at the reaction carefully. This is the first reaction, second reaction, and third reaction. And this three of the reactions, equilibrium constant of the three of the reaction is given, K1, K2, K3. We need to calculate the equilibrium constant of this new equation. Now, what you need to do, you are going to make this equation with the help of three equation, above three equation. So how you are going to do it? If you will look at in the first equation, you can see 2 moles of NH3 on the right hand side. And if you are going to look at the final equation, that is 2 NH3 on the left hand side. Moles are same, but they are on the left hand side. That means they reversed the first equation. They reversed the first equation. Then go for the next reaction, that is N2 plus O2, and you are not able to see N2 here because maybe it has been cancelled. So don't worry about that. N2 now, but O2 is given in this and this equation. So you are going to think about NO. 2 moles of NO is on the right hand side, and you can see 2 moles of NO on the right hand side. That means it just added the second equation as it is. Now go for the next equation. H2 is here, and you can see H2 is not present in the final equation. That means it may be cancelled. Then go for O2. O2 is also in the both equations. So go for H2O directly. H2 on the right hand side of 1 mole, but here H2 on the right hand side, but 3 moles. That means this is multiplied by 3. The third equation has been multiplied by 3. Now, if you are going to reverse it, what you need to do? 1 upon K1. Whenever reaction is reversed, it will be the inverse. Then for equation 2, it is as it is, that means K2. And for equation 3, it is multiplied by 3. So whatever is the multiplication number, it will be in power, and then add it, and you will be getting the final reaction. So what I told you, when you are going to get an equation by adding two or more reactions, you just need to multiply it, and according to that, 1 upon k1 into k2 into k3 raised to the power 3. So you can see k2 into k3 raised to the power 3 upon k1. So our answer will be k. Isn't it easy? Yes or no? Mamuna, Alan, Hanifa, Farhad.
Yes.
So how did it got K3 raised to power 3 again?
See, this is the third equation. Third equation in H2O is 1 mole, but in final equation it is 3 H2O. How will it become 3 H2O? You have multiplied. That means it has been multiplied by 3. And I told you, if a reaction is given like this and K is there, and if you are going to multiply it by any number in the whole equation, its equilibrium constant will be the equilibrium constant of the previous equation raised to the power multiplied number n. Here it will be n because we multiply it by n. Are you getting my point?
Yes, sir.
Can we move to the next question?
Yes, sir.
Okay. Similar question I'm gonna give you. Two question I'm gonna give you. That is question number 7 and question number 8. Here we go. Any answer for the question number 7?
1 minute.
Let's go. Set. Question number 7. Very good. Go for question number 8. Mamuna, is this for question number 7 or 8?
7, sir.
Very good. Seven is quite easy. Let me know if you're done with this. Very good, both of you, Alan and Sir. Yeah, is this? Yeah. Okay, I'm gonna share this slide and then explain and then move to the next question. So, Saif, Mamuna, are you able to see the screen?
Yes.
Yes, sir.
Okay. So, two reaction is given here and here, and it's, am I audible?
Yes.
The host muted. Okay, it was by mistake. So basically, what I was saying is that two reaction is given, this and this, in which K1 and K2 is also given. That means it's equilibrium constant of reaction 1 and 2, and we need to calculate the equilibrium constant for this reaction. So from where this reaction comes, it's very easy, because as you can see, this reaction is has been come from this two reaction. So you can see NO2 on the left hand side, and NO2, if you are going to search, it is on the right hand side of the equation second reaction. But here you can see it is 2 mole and it is half mole. That means basically, first of all, in second equation, it reversed. First, it reversed and multiplied it by 2. What I want to say, it's very simple. Basically, K2 is the equilibrium constant of this reaction. And if you are going to reverse it, it will be 1 upon K2. And you can see 2NO2, 2 moles of NO2 was there, but here it is only 1 mole of NO2. That means it has been multiplied by half. That half will come in power. Okay. Now, if you are going for next half N2, and you can see N2 is on the left hand side, first of all, and 1 mole. And in here, you can see N2 is on the right hand side. That means it also reversed. So if you are going to reverse it, it will be 1 upon K1, and you multiplied it by half. So it will be in power. Now, if you are going to add this, add this two equation, you will be getting this equation. So you just need to do the multiplication of this and this, and you will be getting 1 upon K1 K2. You can write like half, power half, and you can also write like under root K1 K2. So accordingly you can choose your answer. Wait a minute. What will be the answer? Yeah, it will be C. Yeah, it will be C. Everyone done with this?
Yes, sir.
Okay. The one question that was about the Kp and Kc, which is not equal to Kp and Kc not equal. So it's very simple. You know, Kp will be equal to Kc when delta Ng will be equal to 0. If delta Ng will not be equal to 0, then it will not be equal. So if you are going to calculate this, for this delta Ng will be equal to 0. For this delta Ng also equals to 0, because 2 moles of gaseous product, 2 moles of gaseous reactant, it will be equal to 0. This will also be equal to 0. But if you are going to calculate this, you can see you will be getting -1. So the answer will be D. So I think it's very easy, right? Can I change the slide?
Yes, sir.
Now moving to the main chapter, which is amines. Have you revised, everyone revised the chapter amines? Oh, yes or no, please do let me know. Okay. See, amines, first of all, just wait a minute. First of all, we are going to see the IUPAC nomenclature. If you are going to talk about IUPAC, it will be alkane plus amine. So alkane amine it will be. Alkane amine. Like if you have this, you are going to write the numbering like this. This is your main functional group. And you can write its name, propane amine. There is no branch in this, propane amine. And it is 1 degree amine. Now, if you are going to write, you can write like this. So there is a branch in this. There is a branch in this. And for numbering, we actually write N-methyl, since this we are going to take it as substituent. So N-methyl propane amine. N-methyl propane amine. And if you are going to write this, so you can write N comma N dimethyl propane amine. So this is how we do nomenclature of this. Please do write it. Let me know when you are done with this. Now we are going for preparation of amines. Preparation of amines. So see, preparation of amines is from reduction of nitro compounds, NO2, nitro compounds. So as you can see, if you have a nitro compound, you are going to use Sn plus HCl, 10 plus HCl, or either you can use Fe plus HCl, or either you can use H2 plus nickel catalyst. This will be reduced. This will be reduced directly to RNH. To RNH. So basically, oxygen will be removed, which means reduction is taking place, and also hydrogen is added. So in this way, we prepare amine from nitro compounds. Is that clear?
Yes, sir.
Okay. Now the next is basically ammonolysis of alkyl halide. ammonolysis of alkyl halides. So if you are going for ammonolysis of alkyl halide, I'm going to take alkyl halide here, and you are going to react this with ammonia. So ammonia is basically NH3, and I'm going to write this ammonia as this HNH2. And as you can see, why I wrote it like this, as you can see, this will have negative, this will have positive, this will have negative, this will have positive. Positive will go with negative, negative will go with positive. So you can see what we will get. It's very simple. First of all, this will go like this, X negative. So X negative, and how can we write this? Just wait a minute. We can also write like this. Wait a minute. Not gonna show it like this. Okay. Just lone pair will be present on nitrogen. So if it will move like this, you can see R will have positive charge. So R will have positive charge. So this will be attacking on the R. That means this nitrogen will be making a coordinate bond with alkyl group, and it will have positive charge, and X has negative charge. So there will be ionic bond. So basically NH3 positive and X negative will have ionic bond, and R and NH3 has coordinate covalent bond. It is also covalent bond, which is a special type of covalent bond that we call coordinate covalent. After getting this salt, if you are going to mix this with NaOH, or if you are going to react this with NaOH, you will be getting 1 degree alkyl halide RNH2 along with a salt NaX and water. The most important point here is that the reactivity, order of reactivity of halides with ammonia or with amines, basically with amines, will be Ri, then RBr. This is very simple since Cl is a very good leading group, that's why it comes before that. So it's very easy. Please do write it. Let me know when you are done with this. Everyone done with this?
1 minute. Yes, sir, done.
No. Now the preparation is from reduction of nitrites. Now we are going to reduce nitrites from reduction of nitrites. So if you have nitrites RCN, you know that it is RC triple bond N, and you are going to reduce it. And to reduce it, you are going to use a strong reducing agent like lithium aluminum hydride, or you can use sodium in the presence of C2H5OH, alcoholic sodium, or either you can use H2 in the presence of platinum. So this will be directly reduced to RCH2NH2, primary amine. It's very simple. You are just going to break this bond. Hydrogen will be added here. Hydrogen will be added here. Another bond, hydrogen will be added here. Hydrogen will be added here. And in this way, you can easily do this. But always remember, if you have isonitriles or isocyanide like RNC, and you are going to use this reagent to reduce it, you will be getting secondary amine. Isocyanide will give secondary amine. Cyanide will give primary amine. Please do remember this. It's very important. Everyone done with this?
1 minute, sir. Done, sir.
Okay. Now we are going for a reduction of amides. Basically, what will you get by reduction of amides? So basically, we are preparing, or we are preparing amines. So if you have amide, so you can reduce it to form or to prepare amines, and reduction will take place with H2 in the presence of nickel, or either you can use LiAlH4. So this will be converted into NH2. As you can see, this both will be bond will be broken. Hydrogen will be added here, hydrogen will be added here, and H2O will be removed, eliminated, and you will get directly amine. Let me know when you are done with this. Are you done with this?
Yes,
Sir?
sir.
Okay. So, wait a minute. The next is from Gabriel Halimai. So, this is also comes under name reaction. Gabriel Halimai synthesis. Gabriel Halimide synthesis. So basically, first of all, used for preparation of primary amines. And always remember that aliphatic amines, not aromatic amines. Aliphatic, only aliphatic. So how we are going to prepare primary amine, and it will be aliphatic, not aromatic. So we are going to use halimide first. This is the structure of halimide. One of the questions that we covered in the last class, yesterday's class, you can see in the reaction halimide formed there. So this is your halimide. This is what halimide. So first of all, you are going to react this halimide with KOH. And you know that this will have positive, negative, OH negative it is. So this will have negative and this will have positive, and this will have positive, this will have negative. So it will go with this, and it forms a salt. Like this, you can see this is your C double bond O, and this is also your C double bond O, and this is your N negative and K positive. After getting this salt, you are going to react this with alkyl halide, that is Rx, and again follow the same rule, negative, positive. So this positive will be going with this, and you will be getting an alkyl halimide. That means you can see this is your C double bond O, and again C double bond O, and N negative. With N negative, R will come, and this becomes N alkyl. R is alkyl group. So N alkyl halimide. Now, after getting this N-alkyl halimide, you are going to pass this through NaOH, aqueous NaOH, and then you will be getting, you can see, this will be converted into this O negative, Na positive, O negative, Na positive, and this part Rn will be converted into NH2, which is 1 degree amine and which is also aliphatic. So this was all about the aliphatic, Gabriel halimide synthesis, and it is very important as there has been questions that is asked in aldehyde and ketones which is related from this. Let me know if you are done with this. Are you done with this? Saf, Mamuna, and everyone. Hanifa, Alan,
1 minute, sir.
Farhad, Aksa. Very good.
Done, sir.
Okay. Now see the last methods of preparation is this Hoffman, and Hoffman is also very important. Hoffman bromamide degradation reaction. Hoffman bromamide degradation reaction. Basically, whatever is the number of carbon in amide, basically this also from amide, but you have seen that from amide, if you are going to reduce it, you will be getting amine. But this is another name reaction, Hoffman bromamide. So this is also for primary amines, and this is for both aliphatic and aromatic. Now see what will happen here. If you have amide and you are going to react this with Br2 in the presence of NaOH or KOH, what will happen? You know, whatever is the number of carbon in amide, the number of amine, basically the number of carbon in amine will be lesser by 1 in this. So basically this part will be eliminated and it will be directly connecting with this and it will form amine. First of all, primary amines, along with formation of NaBr, a salt, that is Na and Br, and then also carbonate. This carbon forms carbonate. That's why this is degradation. If you have 5 carbon in amide, you will be getting an amine which will have 4 carbon. Are you getting my point, everyone? It's very easy, right? You can also balance it. If you are need to do it, you will be multiplying it by 4 and this will be multiplied by 2. And then you can balance it by your own. Please do this. Everyone done with this?
1 minute, sir.
Okay.
Yes, sir, done.
Very good. What is the name of the product that you have got here? Have you solved it?
Yes.
What is the name? You can see how many number of carbon is there? 3 carbon.
Ethanamide.
Ethanamide. That's good. And the rest is your byproduct that you will be getting NaBr as well as Na2CO. Please do this. No, not any sol. Why it will form any sol? It will form, first of all, this is your benzene amine. This is your amide. So if you are going to react this, there will be formation with Br2 in the presence of base. Then you will be getting an amine. So what amine you will be getting? You just need to remove this and add this directly to this, and you will be getting this aniline, not anisole. Okay. What you did
Yes,
here?
sir.
You just removed this and connected this. What you did here? You just removed it and collected this. Okay. Can we move to the next part? Mamuna, Saifullah, Hanifa, Allen, Farhat,
Yes, sir.
Hiba. Now see, we are going for basic character. Basic character. Chemical reaction, basic character. First of all, everyone knows that basic strength, if you are going to talk about basic strength, you know that it is directly proportional to plus I and plus I. The compound which is connected with more plus I with electron donating group, that will be more basic. Now see, what I want to ask is that, can anyone tell me which is more basic, NH3 or aniline, benzenamine? What do you think? Which one will be more acidic or more basic? See, always remember this point, which is very important. NH3 and aliphatic amines, which are not aromatic, not in benzene, aliphatic amines are more basic than aromatic amines. Why it is so? Because you know this is lone pair to donate and it increases its basic character. This also has lone pair. So what is the difference? Difference is that this lone pair is busy in resonance, so it will not be preferred for this benzene to donate this lone pair. It will not be easily donated because it is in conjugation with benzene ring. So this lone pair will be busy in resonance, but this lone pair is free and it can be easily donated. So this will easily donate. That's why NH3 ammonia and aliphatic amines like CH3NH2 will be more basic than aromatic amines. Are you getting my point? Everyone.
Yes, sir.
Now, if I'm gonna ask you a question about this, can anyone tell me which one will be more basic? Which one will be more basic? Any answer?
Third one.
Which one will be more basic? Basically, you need to arrange this in increasing or decreasing order of basic character, basicity. Any answer? Which
Third
one will
one.
be more? See, no answer, not at all. I told you, generally a student does this because there will be plus I effect from one side, two side, and from three side. This is only true for, this is only true for gaseous state. If amine is in gaseous state, then this will be true. That means 3 degree will be more basic than 2 degree than 1 degree. It will not be valid in aqueous state. Why? Because of three reasons. First reason is steric hindrance, then comes your solvation, and then comes your steric hindrance. I already told you. There are three reasons why. I'm going to write it. This is not true for aqueous system, aqueous solids, aqueous solids. Why it is so? I'll tell you. It is not true for aqueous solution because of first steric hindrance. The second is solvation. Which one will be more soluble? Which one will be less soluble? The third one is inductive effect. Inductive effect. Now you have to be careful about this. If I'm gonna give you CH3NH2, if I'm gonna give you CH3 NH, and if I'm gonna give you CH3 and CH3 and CH, when R is your methyl, we came to know secondary will be the most basic, then comes your primary, and then comes your tertiary. Then comes your tertiary. But when you are going to apply the same thing in ethyl, if your R is ethyl, that means C2H5 NH2, then comes your C2H5 NH, and then C2H5, and then comes your C2H5N and C2H5N. By considering all these three factors, 2 degree in this is also more basic, and then comes your 3 degree, and then comes your 1 degree. After this NH3 comes, after this NH3 comes here, after this NH3 comes. So you have to be careful in both, whether it is alkyl, methyl or ethyl. Secondary will be the most basic. Since after this is your primary, so in between this, primary will come 1 degree and then tertiary. So you have to learn this. This is very important. Let me know when you are done with this. Can I change the slide? The chemical reaction of this
Yes,
part
sir.
is quite easy. First, we are going to talk about acylation. That means acyl halide. We are going to react this with acyl halide. So if you have primary primary amine and this is your acyl chloride group. So you know what will happen. First of all, this will go and there is a lone pair which will directly be attacking here. And then you will be getting C2H5 and hydrogen is there also. Hydrogen is there, and this made a coordinate bond with this on negative and Cl, and then there is CH3, and you can see there is positive charge because it donated electron. Now, what will happen? As you can see, this chlorine is more electronegative, or we can say poor nucleophile. That means good living group. It will live, and then this will be attacking here, and you will be getting C5. And also, it's very important to note that. Wait a minute, I'm gonna show you. Yeah, this will make a nitrogen will take electron from hydrogen to stabilize itself or to make itself neutral, and it will be like this: C double bond O CH. So this has a name ethanamine, which converted into N-ethyl ethanamide, N-ethyl ethanamide. So this acylation is possible in 1 degree and 2 degree only, not in 3 degree, because in 3 degree, nitrogen will not have any hydrogen. You can repeat the reaction with 2 degree as well. You can repeat the reaction in 2 degree as well. I'm going to do it by shortcut. You can see it will be completed in a single line. This is your C2H5, and I'm going to write it hydrogen like this and chlorine like this and C double bond OCH3. What you need to do, just remove this HCl and make a bond between this. So C2H5 and then nitrogen, then C2H5, and this will be directly connected with C double bond OCH. So this is your N, N diethylethanamide. This acylation is possible in 1 degree and 2 degree, not in 3 degree. Always remember this. Let me know when you are done with this. Are you done with this?
1 minute, sir.
Okay.
Done, sir.
Okay. Now the next reaction is carbylamine test. Carbylamine reaction. And this reaction is used to distinguish between primary amine from secondary and tertiary amine. So I'm going to write a point used for distinguish primary amine, whether it is aliphatic and aromatic, from secondary and tertiary amine, from secondary and tertiary amines. So basically what we do here, when we are going to react a primary amine with chloroform in the presence of base, then you will be getting this compound, isocyanide, along with 3KCl plus 3H. This is your primary. Please do write it. And this should be alcoholic. You can write. Just wait a minute. Let me know when you are done with this. And this substance is bad smelling or foul smelling, you can. It is isocyanide or it is called carbylamines. And let me know if you are done with this. Are you done with this?
Yes, sir.
Okay. The next reaction is reaction with nitrous acid. Reaction with nitrous acid. That means basically NaNO2 in the presence of HCl, that will give you HNO2, which is nitrous acid. So the first one is primary aliphatic amines. Primary aliphatic amines. So if you are going to react this, first of all, this is used to distinguish aliphatic and aromatic primary amines. Aromatic amines which should be primary. So this reaction is used to distinguish between aliphatic amine and aliphatic aromatic amines. So if you are going to react this with nitrous acid, as I told you, NaNO2 plus HCl, or you can directly write HNO2, then you will be getting alcohol plus NH2 plus NaCl. If this amine will be aromatic, then benzene diazonium group will form. If you have seen the reaction in first chapter, Sandner's reaction. So if this R will be replaced by AR, that means benzene, it becomes aromatic amine, then diazonium chloride will form. So this is how we differentiate between primary aliphatic amines and second and aromatic amines with the help of this nitrous acid. Is that clear? B, we can take aromatic amines. Again, the same reaction. This is Sandmeyer's reaction. If you have AR, that means benzene is connected with NH2, that is aniline, benzene amine. And if you are carrying the reaction where nitrous acid and the reaction is at cold 0.0 to 5 degrees centigrade, or you can write 273 to 278 Kelvin, then you will be getting ArN2 plus Cl minus, which is benzene diazonium chloride. Benzene diazonium chloride. So it's very simple. Let me know when you are done with this. Are you done with this? Oh. The
Done,
next
sir.
reaction is reaction with aryl sulfonyl chloride. And first we are going to react this with the primary. So I'm going to write benzene sulfonyl chloride. Benzene has a formula C6H5. It has exactly C6H5, C6H6, but sulfonyl chloride is connected. So this will be the formula of benzene sulfonyl chloride, which is also known as Hinsberg reagent. Hinsberg's reagent. First of all, we are going to react this with primary amine. Reaction with primary amine. So first of all, I'm going to react this in this way. You can see this is your benzene sulfonyl chloride. I'm going to write the structure. This is your benzene sulfonyl chloride. And if you are going to react this with primary amine, I'm going to show it like this, RNH2. And then you just need to remove this HCl. If you are going to remove this HCl, just wait a minute. If you are going to remove this HCl, what will happen? You will be getting sulfonamide. This is what you will get. And again, similar reaction will be done in secondary amine. Sorry, secondary amine, yes. So if you have secondary amine, so this benzene sulfonyl chloride, you can see, will be reacted in this way. If it is secondary amine, it will be NH and R will be there, and there will be hydrogen. And then you are going to remove this HCl. Then you will be getting, I'm going to write this HPH, S double bond O, and then NH, and then R. First of all, this is in which one hydrogen with nitrogen is there, it will be soluble in alkali. If you are going to use alkali, it will be soluble. Always remember that. There has been question which is asked which one is soluble and which one is not. So this is your benzene sulfonamide, N-alkyl benzene sulfonamide, and this is your N dot N comma N dialkyl benzene sulfonyl amide, and it is not soluble. It is not soluble. So I'm going to write here, if you are going to dip this in alkali, it will be insoluble. But due to this hydrogen, it will be soluble. Just wait a minute. I just don't write because I have written it wrong. Now this is your second. This is your secondary, in which only one hydrogen is there. And tertiary does not react. This is very simple, right? With tertiary, there will be no. And the rest part you can easily do. I'm going to share the page and then again the same thing will be repeated. What is your electrophilic substitution reaction and all. Now see, I'm going to give you this. Okay. So this is the first question. Please do it. Which of the following amine will give a carbon amine test? Carbon test to distinguish between primary and aromatic hydrocarbons. What is the answer? So it's very easy, as you can see. Which of the following? This is your aromatic. So this will be your answer. Question number 2 is very easy. We just studied about this. The amine that reacts with Hinsberg reagent to give an alkali insoluble product is. What do you think? Please do let me know. This is your option B, C, D. Insoluble product. C is the wrong answer. Because this is your tertiary, it will not react with Hinsberg reagent. This is your primary. It will react, but it will give soluble. This will be soluble. Now, if you are going for this is 1 degree, which will be soluble. As I told you, secondary amine will be reacting with Hinsberg reagent, but this will not be soluble due to absence of hydrogen. If it is tertiary. There is absence of hydrogen and it will not react with Hensberg reagent. Is that Saifullah?
Yes, sir, clear.
Question number 3. Very good. So this is your R is methyl, and as I told you, whether it is methyl or ethyl, it will be 2 degree. If it is methyl, then the second 1 degree, then comes your 3 degree. So you can see methyl. This is your 2 degree. This is your 1 degree. This is your 3 degree. So the option will be A. Very good for her. Just wait a minute. Now you are going to do this. Question number 8. See, I'm going to explain this question. Electrolytic reduction of nitrobenzene. First of all, you are going to reduce this nitrobenzene with the help of FeHCl or SnHCl, and it will be converted into NH2. Now, in a strongly acidic medium, if you are going to do this in a strongly acidic medium, this will be converted into, basically it will be a single step reaction, NHOH. Hydroxylamine will be there, and then there will be rearrangement, and this OH will come to the para in order to stabilize itself. So this is what you will get. OH will be at para, P-aminophenol, P-aminophenol, para-aminophenol will be our answer. D, not C. Amine will be there, but after that, nitrobenzene, you can see a strongly acidic medium produces. So a strongly acidic medium, hydroxylamine will form, and after that, rearrangement will take place. There is rearrangement. Let me know when you are done with this. Everyone done with this?
Yes, sir.
Okay. Please do question number 5. Question number 5. See, very good. Very good. So it's very easy. Third will be the most, then comes this, and NO2 decreases it. That's why it's C. Very good. Question number 6. Very easy. Any answer? Okay, see, acetamide methanamide. If you remember, this was your amide, and by using Br2 in the presence of NaOH, you just got whatever is the number of carbon in amide, you will be getting an amine which is lesser by 1 in number of carbon. So if you aceta, that means ethanamide, it is 2 carbon, and you will be getting methanamide just one number less in carbon. So the answer will be A. It's very easy, right?
So why is it called hypobromamide?
Oh, hypobromamide. Wait a minute. So basically, maybe there is a misprint. Hypo is hypobromamide. We cannot say that. Bromamide, Hoffman bromamide reaction is this. It is called. Hypo, maybe it's a common name.
Okay, sir.
Hypobromamide. Hypo we generally use. Okay, it is also known as hypobromamide. I just checked it. Okay. Just wait a minute. Most basic question number 3. 13, sorry. Most basic. B is the right answer. Very good. So as everyone can see that this lone pair, this lone pair, this lone pair, every lone pair except B will be in conjugation with the benzene ring, and it will be in busy in resonance. But this can be easily donated because this is not busy in resonance due to conjugation. It is not in conjugation, so it can donate it to some other, and it will be the most basic. Okay. So this is it for today in your test. There will be a main chapter. So almost I covered all the concepts except the diazonium, which is quite easy. You can do it. And that reaction we have already studied in haloalkanes and haloarenes. So I will see you in the next class, and we will start ionic